any textbook. Okay, this you can easily verify. Another one, third point. If W is a subspace, no, sorry, W is subspace. There is no if. W is a subspace if and only if L of W equal to W. If W is already subspace, then linear span of W you will not get any extra. You will get W only. Okay. If L of W is equal to W, then L of W, any linear span of S is a subspace. So W is subspace. So both sides you can see. If W is ఒకవేళ W subspace అయిందనుకో L of W లో ఇంక ఎక్స్ట్రా ఏం ఎలిమెంట్ ఉండవు, W నే ఉంటుంది. ఓకే, ఎనీ లీనియర్ కాంబినేషన్స్ యూ టేక్, W subspace అవుతుంది కాబట్టి అన్ని లీనియర్ కాంబినేషన్స్ ఆఫ్ ఎలిమెంట్స్ ఇన్ W will be in W. W లోనే ఉంటాయి, అందువల్లనే L of W is equal to W అవుతుంది. ఓకే, yes. So from here we can see another one, fourth. L of S equal to L of S. Linear span of S is equal to L of S. If you take L of S, then if you take linear span, you don't get any extra. You will get linear span only. Okay, for any subset. Okay, and fifth one, if S1 is subset of S2, then L of S1 and L of we'll use space here, L of S2. So what can you say about which one contains which one here? If S1 is subset of S2, L of S1 is subset of L2, or L of S2 is subset of L of S1? So we will see L of S1 is subset of L of S2. Okay, this is important. Okay, this kind of properties may be given in the options, in the questions. Okay, theoretical problems also can be asked. And this also we can see from here. We can see that if W is a S subset of W, 6 1 S subset of W, subset of V, and where W is a subspace and S is any set. Then we can clearly see that L of S is subset of W only. L of S is subset of W. Then L of S is subset of W. Okay, clear, right? Because L of S is the smallest subset containing S. If L of S ఏంటిదంటే smallest subspace containing S. ఇక్కడ W కూడా subspace containing S ఉంది కాబట్టి L of S చిన్నది కాబట్టి L of S will be subset of W. Okay, it's a property of L of S. Okay, so we'll see some problems now. Let W
L of S subset of V కూడా అవుద్దా సార్?
L of S always subset. V is అనేది వెక్టర్ స్పేస్ కాబట్టి L of S అనేది వీక్ సబ్సెట్ గానే డిఫైన్ చేస్తాం. సో ఇట్ ఈస్ ట్రూ, L of S is always subset of V. డెఫినేషన్ లోనే L of S is subset of V. Okay, so V is there, W is containing V in V, and S is containing this L of S, that is L of S, and S is smaller. So we have this kind of inclusions. Okay, so we'll see problems. One, let W equal to P belongs to R of X such that P of 1 equal to 0. Then here we are taking usual operations. It is a subset of R of X, but it can be equal also with use R. What is R of X? Do you remember? It is space of all polynomials. This is standard notation I am using. Okay, space of all polynomials. Okay, then options. A, L of W equal to R of X Second option, L of W equal to W. Third option, W is proper subset. W is proper subspace of L of W. D, W is not a subspace of R of X. W is not a subspace of R of X. Yeah, tell me in the chat box. Tell me the answer in the chat box. Answer చెప్పండి chat box లో చెప్పండి. ఏది కరెక్ట్ ఇక్కడ? B, somebody is saying B. Okay. Yeah. Yeah, Bhutta Shiva Prasad is correct. Sanjay is correct. And Chinta Kotla Shankar correct. Santosh correct. Think. Okay. Think చేయండి. W గురించి ఆలోచించండి. W ఏమవుతుందో చూడండి. Then we can by using above properties you have to say the answers. Okay. If you want, I will show the properties once again. W is a subspace, then if and only if L of W equal to W. And W is a subspace if and only if L of W equal to W. L of W is equal to L of S. S1 is subset of S2, then L of S1 is subset of L of S2. So all those things. Okay. Yeah. Answer is almost everybody wrote correct answer. Few people are saying which option? D. But D is not correct. Why D is not correct? Why W is not a subspace? It is a subspace. Can you check? Because solution. See, first of all, L of W, I will write why A is not true. L of W is not R of X. For example, if you take constant polynomial, P of X is equal to 1. So P of 1 is 1 only, cannot be 0. P of 1, it's a constant, it is 1. So that's why P does not belongs to W. P does not belongs to W, but P is in R of X, right? P is in R of X. So obviously, yeah. So that's fine. Before that, I want to prove that so W is not. So from here we can say that W is proper subset of R of X. Okay. W is not equal to R of X. Okay, we can say, right? W is not equal to R of X. But we have to prove that L of W. But W is a subspace. If we prove that W is a subspace, we can see that W is a subspace. P comma Q belongs to W. Then alpha P, I'm taking two polynomials, P comma Q in W. Then alpha P, alpha is a real number. Alpha P plus Q of, we want to show that it is in W. So I will find out value at 1. Remember here P comma Q are polynomials, okay? Alpha into P of 1 plus Q of 1. So which is alpha into P of 1 is 0, because why P of 1 is 0, Q of 1 is also 0. Why P of 1, Q of 1 are 0? Because P, Q are coming from W. What is the rule in W? P of 1 should be, some polynomial is there, if you evaluate at 1, it should be 0. So that's why alpha P plus Q belongs to W. That implies W is a subspace. Okay. So it is important to see W is a subspace. Once you see W is a subspace, we can clearly say that L of W is, what is L of W? Is W only. So W equal to L of W. We know that property have stated with W equal to L of W. So we have proved that L of W is not R of X. So which is not equal to R of X. See, by proving W is a subspace, we can see two options. First one and C is first one is not correct. C is also not correct. Okay, and what about the B? Why B is correct? So W is a subspace. L of W is B. I'm just checking B. W is a subspace. We have proved. So L of W is W and L of W is W. So we will get L of W. So L of W is W. Clear, na? So we can write B option is correct because L of B correct. So because L of W in the first step L of W is W. So L of W. Once again L of W is W. So we will see L of W. L of W equal to W because W is a subspace. So this one. And what is the D option? Why D is not correct? W is not a subspace. We already proved W is a subspace. So this question purely depends proving that W is a subspace. Once you prove W is a subspace, you can answer this question. Okay, with the above properties by using the properties which I have mentioned. Okay, next question. So this question which I'm going to write, it is a junior lecture question or DL question. V is equal to R2, be a vector space with respect to the following operations. With respect to the following operations. Vector addition x comma y plus w comma z equal to x plus w plus 1 and y plus z minus 2. At scalar multiplication is alpha circle dot x comma y equal to alpha x plus alpha minus 1 alpha y minus 2 alpha plus 2. Okay, so now question is the additive inverse of 2 comma 3 is additive inverse of 2 comma 3 is answers minus 2 comma minus 3, B 2 comma minus 3, C minus 4 comma 1, 4 minus 4 comma minus 1. Yeah, answer in chat box. Okay, use the chat box and tell me. Can you see the screen?
Yes, sir.
Okay. You are thinking that it is more computational, but if you know the properties, you can do within a minute, not even a minute, half minute. Yeah. Who else? Then Chiranjeevi. No, yeah, it's not correct. Anita. Anu. Yeah, Anu, correct. Yeah, minus 4 comma minus 1. Mamta, Srinivas Rao, Vijay Lakshmi. Okay, some of them are correct, but not all of them are correct. Okay, I will do the answer. Okay. So almost all are correct. So we will solve. I will tell you the answer. You have to use one property. You remember in a vector space, what is -1 into V? Solution. -1 into V. What is -1 scalar product into V? Scalar product. It's -V, right? Everybody know this one. This is a property of vector space. So if you take -1 a scalar, multiply with V, scalar multiplication, you will get -V. So here it is given already. With respect to this operation, it is a vector space. So we no need to verify whether it is vector space or not. We simply take -1 scalar, multiply V. So what is V here? 2, 3. So we take -1 scalar multiplication with 2, 3 by using the definition. So alpha into x comma y is alpha x plus alpha -1. Alpha x is means -2. -1 alpha -1 -1, and alpha y means -1 into 2 -2 into -1 -1 into 3. Sorry, -2 alpha means 2 into -1 plus 2. So I'm using this scalar multiplication. I'm using here scalar multiplication, this one, okay? Yeah. So now you compute this one. -2 -1 -4, no, -1, and -3 plus 3 plus 2 plus 2. And -4, comma 1. Is that clear? Other way we may do that. First, you find vector zero vector in this. First, you have to find additive inverse, additive identity, and then you take to 2, 3, and you take its additive inverse is x comma y. Then you add 2, 3 plus x comma y equal to additive inverse, whatever you get. Then you solve the equation. That way also we will do, right? So this is lengthy, right? But this is easy because if you know the properties of vector space. Is that clear? Do you have any doubt?
No.
Okay. So what is a vector? What is additive inverse? Additive inverse means -V we have to find. -V means -V. We know that -V is equal to, in a vector space we have a property. -V is equal to -1 into V. -1 scalar. If you multiply -1 scalar with a vector, you will get -V. What is -V? -V is notation for additive inverse of V. That everybody know, right? The additive inverse of V. So if I want to find out additive inverse of V, I just need to multiply -1 scalar to V. So here -1 scalar, we want to find additive inverse of 2, 3. I'm just taking -1 into 2, 3. So you have to multiply by using scalar multiplication given in the problem. What is the scalar multiplication? You can see this one. Alpha into x comma y is equal to alpha x plus alpha -1 alpha y minus 2 alpha plus 2. Is that clear? I'm using this. So alpha is equal to, what is alpha is equal to -1, x is equal to 2, y is equal to 3, right? Then use this scalar multiplication. Is that clear now?
Yes, sir.
Is that clear?
First condition to explain sir oral ga.
Sorry, I'm not able
Vector
to. Vector addition. So vector addition is defined by like this: x comma y plus w comma z is defined by x plus w plus 1, y plus z plus -2. It's a vector addition. So it's, and is below one is scalar multiplication. So this is defined like that only. So you want to
vector
see
addition to sir inverse cheppara sir oral ga.
oral,
Vector addition
okay.
to inverse.
Okay. So if you use the other way, other method, we can also do other method. Easy to do this. So first we will take 2, what is that? 2, first we will find identity, zero additive identity. Zero vector we have to find. How to find zero vector? x comma y plus alpha comma beta. We need this way equal to x comma y. You have to get. Then what is alpha comma beta? We have to find out, right? So alpha comma beta is the additive identity. So if we want to find additive identity, this equation we have to solve. Isn't it? Correct kadandi? So, but what is this addition given? So we have to go back to definition. So x plus w plus 1. That means x plus alpha plus 1 and y plus z minus 2, y plus beta minus 2, which is equal to x comma y. So if you equate this, x get cancel, alpha is equal to minus 1. And another equation, if you solve y plus beta minus 2 equal to y. So y get cancelled, beta is equal to 2. So what is the zero vector here? Alpha comma beta, zero vector is minus 1 comma 2. Don't confuse with the zero vector 0 comma 0. Zero vector with respect to usual operation. 0 comma 0 is the zero vector with respect to standard operations. But here manakunna operations standard operations kaadu. So we have to calculate zero vector. Okay, that may not be 0 comma 0. For example, here we are getting minus 1 comma 2. Ikkada em vastundi minus 1 comma 2. So this is called zero vector. So it's a additive identity. Okay. So once you get identity, now we will find additive inverse of 2 comma 3. So how do you find additive inverse of 2 comma 3 is 2 comma 3 plus x comma y should be zero vector. What is zero vector? Minus 1 comma 2. So now we use the once again additive formula. What is the vector addition is given? You remember, I'm using vector addition formula, which is given in the problem. Okay, you can recall. So this one, x comma y plus y w comma z is equal to x plus w plus 1 y plus z minus 2. Okay, if you use that one, you will get this. And then 2 plus 3, okay, x plus 3 equal to minus 1 and y plus 1 equal to 2. So x is equal to minus 4, y equal to 1. So x comma y is the inverse of 2 comma 3. What is that? Minus 4 comma 1. Inverse of. Is that clear? So this is a lengthy way, right? So, but if you know the properties of vector space, we know that minus 1 into v is minus v. So if you use that, you will get easily. So within 1 minute we have to do. So that's why we have to use this trick. Is that clear?
Okay, sir. Thank you.
Yeah. Okay. So next. So this one is little lengthy problem. Let us try to do. Let third problem. Let S is equal to